Hello everyone, welcome to this video. In this video, we shall see question from December 2013 consisting of 4.75 marks. The question says, the given integral equation, integration from a to x, kxy, phi y, dy is equal to f of x, where kxx is not equal to 0 for all x. This can be transformed, this equation can be transformed to this equation where and they are asking for what values of these options, right, kxx, gxy and g, could this be done, right? So let us see. So can you notice the first equation, the first integral equation has what form? It is of first kind, right? So you can convert first kind integral equation into second kind integral equation by simply differentiating with respect to the given variable x. So let us do it. So our equation, we'll take this equation and we'll differentiate this. So the equation is integration from a to x, k of xy, phi y, dy is equal to f of x. When we differentiate this, we'll first apply the Leibniz rule, right? What is that? Let me write it over here. The Leibniz rule for performing differentiation under integration, it is equal to, that means we are taking the derivative of this integral term. Here it is something ax or bx. It could either be constants, some function of x and y, right, dy. And so it would be integration from ax to bx, partial derivative with respect to x of the function uxy, dy as such, plus the derivative of this upper limit with respect to x and this whole term where we replace y with the upper limit, and minus the derivative of this lower limit with respect to x multiplied by u, the u term where we replace y with the lower limit. So this is the rule, Leibniz rule. So let's apply this rule, right? So it would simply be, here we have integration from a to x, the partial derivative of k x y phi y dy as such, because here the derivative is being taken with respect to x only and keeping y as constant. So we are only taking the derivative of this kernel term plus the derivative of upper limit, that is x. So its derivative with respect to x would be 1. So 1 into the value, all other values where y is replaced with x. So it would be kxx multiplied by phi of x, right? And lower limit would be minus the derivative of lower limit, a constant would with respect to x, that would be 0. So this whole term would be 0. This is equal to f dash x. So I hope this is clear. So now let us look at our options and the given structure. Now they are saying we need to convert it into this form. So can you see this form from here? No. Or we can check out the options. The first option says if kxx is 1, that means this term is 1. Let me write it down. The first option say kxx is 1, g is equal to f dash, and gxy is equal to this thing. So it would be integration from a to x. I am putting all these values over here. So it would be integration from a to x. It would be gxy, right? And phi of y dy plus kxx is 1. So we are only left with phi of x is equal to, and g is equal to f dash, so it would just be g of x. So now let me look at the given form. Phi of x plus integration from a to x gxy phi y dy is equal to gx. So our form is also the same, so this is the correct option. Let us look at the second option. In second option they are saying kxx is 1, g is equal to f, and gxy is equal to 0. So just substitute these values over here in this equation. You'll see what do we obtain. So here they are saying gxy is equal to 0, g is equal to f, and kxx is 1. So this terms becomes 1, this becomes as such, and this becomes 0. So we do not reach at this form, right? So this option is discarded. Just substitute the values and you'll see by yourself. For the third term, let me write it like this. So they are saying gxy is equal to this term. So we have this term and division by kxx, and gy is equal to f dash division by kxx. So we can divide this whole equation by kxx. No harm in doing that. So it would be 1 by kxx integration from a to x. So curly by curly x of kxy phi y dy plus phi of x is equal to f dash x divided by kxx. Now can you see the form? Now just equate this one and the given equation. The given equation is this, right? So let us look at the equations. So phi x plus integration from a to x, whatever is this thing, this is g of y, and g of y in this case is this, the same as this. And if you see the right hand side, it is equal to g of x and it is equal to g of x. So this is the form, right? And for the last option, so this option is correct, this option is correct, this is incorrect. And what about the last option? They are saying gxy is equal to 1. That means this whole term becomes 1, and g is equal to f, so this becomes f. Now can you see, are they equal? So phi of x, simply phi of x plus integration from a to x phi y dy is equal to f. So this is not the case in our case. So this is also not the correct option. So the only correct options are A and the option C. I hope you understood this question. This was a very simple question. What you need to know is how to apply differentiation under integration sign, right? Using the Leibniz rule. And so that when you just differentiate this, you'll get this equation with some values over here. So thank you for watching.